Hey guys, Phil from Fluidampr here. We're going to go over a little bit of the testing equipment and stuff like that from 3 previous videos. So far we have my initial introduction, you guys just getting to know me a little bit. We have the damper install on my truck, and we have the initial reactions, initial startup test drive from the install. Joined with me today is Aaron. Would you mind explaining to us a little bit of what you do with the company?
What I do is I head up the design engineering, and what we do is we take customer input, OEM parts, and any additional requirements, and we go through and design Fluidampr that will meet those requirements, and then also comply to SFI spec 18.1, and also make sure that it provides adequate engine protection for performance racing applications. From there, we go through and do testing to make sure that the part's going to work. We got our prototypes ready, and then we schedule testing, typically with the original point of contact customer, and then we'll go through and validate the part to make sure the part's working properly, and then so that way it works right out of the box. The customer doesn't have to do any tuning. It's a good part, it's ready to go, and we have confidence that the part's going to work well, which helps our sales team have more confidence in selling the parts.
That testing definitely does help us explain to the customer exactly what's going on, what they can expect out of it. Here in front of us we have a little bit of equipment. Would you mind telling us a little bit about the testing sequences, phases?
So what we have here is our Rotec FFT analyzer, and what we do is we use this to measure the torsional vibration that the engine puts out. What we typically do is we'll attach a speed sensor, shown here, and on this particular test we set up a bracket on your truck to read the flywheel and the gear teeth from the starter ring gear. And what we're able to do is measure the RPM of the engine at a very high resolution, so we can actually see your RPM changing as we drove up and down the road, and not just gaining RPM as we rev up, but even at steady state your RPM is always fluctuating, and that's what torsional vibration is. So like if you had a high resolution tack, you would see that move right on the dashboard, but most tacks aren't high resolution, just so that way you don't see that. But what this has is, take maybe 30 times more measurements than your tack would see. And then we can take that and convert it into angular displacement. And what we're trying to do is test that RPM fluctuation across the speed range and make sure that the Fluidampr is better than that. So it's just kind of a way to put a number to how well the damper is working. So I would imagine after you had the part installed, you maybe even felt a difference in the truck when you drove it next.
There definitely was. The OE damper original, when we were looking at it, you could definitely tell that it was on its way out. There was rubber squishing out from between the inertia ring and the hub. When you're sitting in the driver's seat, engine running, you'd feel a little bit of vibration through the steering wheel, a little bit through the pedals. When you're under the hood with the engine running, you definitely hear the RPM fluctuate here and there a little bit. Quite a bit of shudder between shifts. There was some hard shifting, whole 9 yards with that. Now, that's all the style stuff that we're looking for when we're doing the testing.
That is what we're looking for, and then but some other things that we try to look for too is we want to, like you said, we want to make sure we reduce the vibration amplitudes, and we want to make sure that we provide a part that's durable, that's going to last, unlike the rubber part, how you mentioned it was starting to come apart. Those are technically a wear item in the service manual, whereas a Fluidampr won't be a wear item. It'll last the life of the engine. But as to what else we were looking for, for this testing, we're going to actually look at some of our footage from when we did the testing from in vehicle.
For our testing, we chose a fairly decent sized hill, pretty long straightaway, just enough that we could get a load on the truck. We ran through the gears, started from a dead stop. As soon as first gear hit, I do believe it was, we started recording.
Yes. Yep. We started soon after the first shift to maintain consistency. So from the bottom of second, was able to capture all of the RPM fluctuations from all of second gear, third gear, and fourth gear. So that way we would have a full picture of what's going on with the different gears. We can look at vibration amplification through the gears and anything related to that. And then we were able to collect 3 data sets on the OEM damper and 3 data sets on the Fluidampr. So we had so we could go through and make sure that all of our data was reliable and consistent. Having the long hill also helped because that gave us enough time to get through the RPM range without going so fast that we would miss any potential vibration resonance. As we were doing that testing, can you kind of go through a little bit of how, what anything you noticed different in the truck just from driving standpoint?
After we did the damper install, there was less vibration through the steering wheel. There was less through the pedals. It definitely felt a lot smoother during the shift points. Came up to speed a little bit faster. We kept the truck in the same tune. I didn't change any of the tunes. I wasn't any harder on the throttle. Overall, it felt a lot better. Can you give us a little bit results between the 2 tests?
Yeah. So to go along with the improvements in feel that you felt, I mean, that's always something that I would say every time you install a part, you're always going to feel something different. And we've all been fooled by the butt dyno before. So one of the big reasons why we went through and took the vibration measurements with our equipment was to make sure that we could throw some numbers on there, kind of like what we do with horsepower and torque charts when we're doing dyno tuning or dyno testing. So we have a chart here that we're going to put on screen, and this chart shows the vibration comparison between the OEM damper and the Fluidampr that we tested. And as you can see, from throughout the entire RPM range for this shift, the Fluidampr outperformed the OEM damper by quite a bit. In this case, unlike a dyno chart, the lower number is actually better because you have less RPM fluctuation. And what that means, typically from an engineering standpoint, what that means is you're going to have less friction on your main bearings. So you're going to have less main bearing wear. You're going to have the crank be more stable with less, your oil films aren't working as hard to stabilize the crankshaft. You're going to have less twist end to end, so you're not stressing your crankshaft as much. You're also going to have a part that is durable and it's not going to have to be replaced as often as a OEM rubber damper. And that's just from an engineering standpoint, but I imagine that from like a pulling standpoint, a performance standpoint, there's some benefits that you could cover, Phil.
Oh, definitely. Overall, with less stress on the crank, high performance part, the engine's going to last a lot longer. You're going to get a lot more time out of it, a lot more reliability out of it. I know personally, I tend to beat on my truck a little bit. I got some pretty good plans coming up for it, and I need my truck. It's my daily driver. It's A to B to work, back and forth to the fire hall. I do quite a bit with it. Pretty much that's about what all the testing entails. Thank you guys for watching. If you haven't seen them already, go back, check out the 3 previous videos. Like, subscribe, keep an eye on the page. More content will be coming out soon. As always, guys, keep it easy.